When we picture an alien planet, we usually imagine the worlds we see in movies, neon skies and landscapes that seem to defy physics. But you don't actually need to leave the atmosphere to find environments that look entirely synthetic. They are actively breathing, shifting, and burning right here. This map shows the known surface of our planet, and it reveals a massive blind spot. We have physically mapped out less than 20% of Earth's landscapes. The other 80% remains completely unobserved. To understand how these bizarre anomalies form, we have to look at our planet's geography in a new way. We're going to take a vertical descent, starting high in the atmospheric peaks, dropping down to sea level, and finally plunging deep beneath the subterranean crust. Finding the truly alien doesn't require looking out into the stars. It just requires a deeper look into our own extreme geography. We begin our drop high above the ground, among the floating rock spires of Zhangjiajie National Forest Park in China. Millions of years ago, this area was one solid block of rock. Over millennia, physical forces like wind and water carved away the weaker stone. What remains are isolated towers packed with dense minerals that inspired the movie Avatar. Moving laterally across the globe to another high-altitude extreme, we hit the freezing peaks of the Andes Mountains. This is Vinicunca. At first glance, it looks painted, with thick pastel stripes dragged directly across the rock face. Those stripes are a raw chemical readout of the Earth itself. The red layers are iron oxide, essentially the same chemical reaction that produces rust. The bright yellow sections are packed with sulfur, and the deep green bands come from concentrated copper minerals. For centuries, this vibrant chemical signature was entirely hidden under a thick cap of snow and ice. It was only recently, as global temperatures rose and melted the glaciers, that the mountain's vivid chemistry was finally exposed. Dropping down to sea level, the anomalies shift from rock to water. Off the coast of Puerto Rico, in Mosquito Bay, the crashing waves glow an electric blue in the dark. That light is produced by tiny microscopic organisms called plankton. When agitated by a breaking wave, these plankton emit a flash of bioluminescence, a natural chemical reaction, as a sudden defensive stress response. Moving inland from the ocean to the arid deserts of Turkmenistan, the water gives way to constant fire at the Darvaza Gas Crater. In 1971, Soviet geologists were operating a drilling rig in the area when they accidentally punched through the crust and into a massive, highly pressurized pocket of natural gas. The ground instantly collapsed, swallowing the equipment. To prevent the highly toxic methane gas from spreading to nearby towns, the scientists made a quick calculation. They would set the crater on fire. They expected the available fuel to burn off in a few days. Instead, that single accidental spark ignited an inferno that has been burning continuously for over half a century. On the surface, the most surreal environments are often forged by the volatile collision between unseen natural resources and sudden human errors. Finally, we plunge nearly 1,000 feet below the surface. If you look closely at the person in the orange suit, you start to grasp the terrifying scale of Mexico's Cave of the Crystals. These are jagged, intersecting pillars of gypsum, a soft sulfate mineral. Some of them stretch up to 40 feet long and weigh over 50 tons, making them about the size of a telephone pole. They achieved this extreme size because the cave was flooded with superheated, mineral-rich groundwater for hundreds of thousands of years, acting as a perfect, undisturbed incubator. But this incubator is entirely hostile to human biology. Geothermal heat from a magma chamber just below the cave pushes the air temperature past 136 degrees Fahrenheit with near-perfect humidity. Without protection, a human would die in that room in under 10 minutes. Just to survive long enough to map the room, researchers have to wear heavy, specialized gear and artificially pack their bodies with ice.